welcome to 6.6, Congruence Postulates. Okay, today's lesson is rather short in my PowerPoint, but I am expecting you to look at the proofs that are in this section. It's really important. So far we know 6 congruence postulates and theorems that we can prove, and these 2 postulates make it way faster. We don't have to have all of the congruent parts to prove 2 triangles are congruent. So let's get started. Side-angle-side is one of the congruence postulates. This section is actually really popular and probably going to be on your OGT test. If it's not exactly written this way, they expect you to know how to figure out if triangles are congruent or not. So anyway, let's get sorry I stopped midway there. Side-angle-side congruence postulate. If 2 sides and an included angle of one triangle are congruent to the corresponding 2 sides and included angle of another triangle, then the 2 triangles are congruent. Super important to remember what included means from section 6.5. Remember, it is the angle in between the sides, and the sides have to correspond. So let's look at an example. Here I have 2 triangles, ABC and DEF, and we're going to talk about how we have, there's one side that is congruent, there's one angle that is congruent, and there's another side that's congruent. Now, if for some reason we had, the second side we had congruent was AB and DE, we would have side-side angle, and that is not a congruence postulate. So it's very important that you know that angle is included of the 2 sides that we have that are congruent. Okay, so angle C and angle F are included in those 2 segments that we have. That's the side-angle-side congruence postulate. So they are congruent. So now that I know that those 2 triangles are congruent, that means everything else on the triangle is congruent. Angle A is congruent to angle D. Angle B is congruent to angle E, and angle AB is congruent to angle DE. The rest of the parts are congruent. Okay, just like we had side angle side, now we have angle side angle. Just like before, we need to talk about the word included. So if 2 angles and the included side of one triangle are congruent to the corresponding 2 angles and included side of another triangle, then the 2 triangles are congruent. So here I have 2 triangles again, and I've got 2 angles and the included side. So now that these 3 parts are congruent to the other triangle's 3 parts, just in this order, okay, if it's a different side, this postulate does not hold true. It has to be included. Now I can prove that they are congruent, and that now all the parts are congruent to one another. Okay, so for the first example, there's a picture that talks about what's given, and we have to prove that the triangle, the 2 triangles are congruent. Now let's just talk about this before you look at the proof, because this is actually a really short proof. If you look, we have a side and an angle already given to us. So we either need to have another angle, so we have angle side angle, or we have to have another side, so we have side angle side. It matters which one we have, right? We either need angle M is congruent to angle O, because then we would have a side included that's given, or we need to have the side LN, because we have the side angle side, that side LN. Now look at it, is LN congruent to itself? Because it is the same segment for both triangles. Okay, so if you just talk it out to yourself like I just did, you will have the whole proof. Now look at the proof in the book. You'll see that's the only step besides the given and the prove that you need, and that's the the reflexive property that Ln is congruent to Ln. Okay, so for the second one, we have the same exact figure, but this time they're talking about bisection, okay? Ln bisects angle MLO, which means those two angles are congruent, right? We just have an extra step to talk about that. And let's see, what else do we have? Oh, it also bisects M and O, which means those two bottom angles of angle N, the two angles at vertex N, are also congruent. Now, it's not marked on this figure, but that's what's given. Okay, and then we have to prove that angle M and angle O are congruent. Now, look, it's really important that you look what you're trying to prove. You're not trying to prove these angles or triangles are congruent. You're trying to prove the opposite angles are congruent. The easiest way to get there is to say that the two triangles are congruent, because now all the corresponding parts would be congruent by definition of congruent triangles. Okay, so again, hopefully now if you go and look at the proof on page 241, you'll be able to follow along with that explanation there. Okay, believe it or not, that is the end of this lesson. It's just these two postulates and getting to know them very intimately. All right, a common error that you're going to have if you have difficulty with congruence proofs, it's sometimes you're being confused by drawings. That's what I've found in the past. Most people look at all the instruments, like say in an airplane, okay, maybe not in a car because some of you are driving now, but let's talk about in the cockpit of a commercial jet. Okay, you may not understand everything that's going on in there. I know I would have no idea. All right, it kind of feels like that sometimes when you're looking at the markings of diagram. You have to learn to analyze diagrams and recognize side-angle-side or angle-side-angle. Okay, so if you need to discuss them like I did when I showed you the two examples, just discuss what you have. We'll try to do some physical models in class if we can, but I just, maybe even in after school and tutoring. So anyway, your whisk summary. You need to draw two quadrilaterals. I know we're talking about triangles, but this does kind of go along. Draw two quadrilaterals with perpendicular diagonals that are not rhombi. Remember what a rhombus is. Okay, if you have to look up the definition of rhombus, that might be helpful to you because you don't want to draw that. And then you got to draw one that's convex and one that's concave. Again, two vocabulary words that we haven't talked about in a while. So this is actually the math over mind in 6.1. So if you want to just look, they didn't give you a picture or anything. This is exactly what it says. So go ahead and submit that to me, and I will see you in class.